Hello, my name is Bob Delorier, and I'll be your instructor for this Introduction to Personal Computers course. You're probably watching this video presentation because you've made the decision to join the rest of us in the computer world, and we know you'll be glad you did. It may look a little bewildering when you're just starting out, but our sole purpose with this tape is to show you that it doesn't have to be that way. Once you've got the hang of it, you'll find that your computer is not only a pleasure to use, but that it can save you an awful lot of work as well. With all the options and programs available, the only thing that's going to limit what you can do with your computer is your own imagination. Today, you can hold in one hand more computing power than was dreamed of 20 years ago. And considering its modest cost, it's an amazing bargain. Modern computers are incredibly reliable, and most of the horror stories that the newspapers love to publish are the result of human error. By the end of this presentation, you will know the names of the basic parts of your computer system. You'll know what each of these components is for, and you'll know something about the programs that control your computer, the software, firmware, and data, and the relationship between them. In this course, you will be able to understand the articles and advertisements for various computer systems, and be able to make informed choices about selecting the right components for the system that best suits your needs. The going will be a lot easier if you speak the language. There's a lot that may sound like techno-speak to a beginner, but as we progress step by step through this introduction, you will find that picking up the language isn't difficult at all. The first big distinction that we'll make is between hardware and software. Hardware is the nuts and bolts of your computer system. It's the physical components and accessories that do all the work together to get the computing jobs that you need done. We'll describe hardware in a moment. Software is the collection of instructions that tell the computer what to do and in what order to do it. Neither hardware nor software is any good all by itself. You have to have both if your system's going to do anything. We'll take a look at the hardware first, and then we'll discuss software. We'll show you with a few examples of how they work together. And then we'll talk a little about the technical information and advanced options that will be available to you. The brains behind the system is the Central Processing Unit, or CPU. As we go along, you'll find that there are some phrases that are used a lot, like Central Processing Unit. Of course, it gets cumbersome to keep repeating them, so it's often easier to understand if we make up an acronym by using the first letter of each word or phrase. So CPU means Central Processing Unit. And if you mention a CPU to someone that's familiar with computers, they'll know exactly what you mean. Strictly speaking, the CPU is an integrated circuit or microchip that lives in your computer's main logic board. It's a miracle of modern design and manufacturing, but it needs a lot of electronics to support it. And this whole collection of electronics is packaged together in one box, which is commonly referred to as the computer, or may be referred to simply as the CPU. In its most common design, the computer is a low, wide, rectangular box like this one. Some are vertically oriented, such as this narrow, tall CPU. You may choose the classic design or the tower model, depending on your own space requirements. Broadly speaking, CPU functions can be broken down into two categories. The CPU moves information around, or it can perform mathematical calculations. The CPU does not think in the sense that we think. It does make decisions based on sets of rules and pieces of information that we give it. In order to do this, we have to be able to talk to the CPU, and it has to be able to talk back to us. In a basic system, there are 7 components that allow us to do this. They are the memory, the hard disk drive, a floppy disk drive, a keyboard, a monitor, a mouse, and a printer. Now, there are a couple of main kinds of computer memory, and they're present in the form of memory chips. First, there is read-only memory, also known as ROM. This is a group of microchips on the circuit board or motherboard of your computer that store basic housekeeping instructions. Next, there's a collection of microchips that act as temporary storage for your computer. At any time, they may contain numbers, paragraphs, or any information that you're currently working on. It's sometimes referred to as working memory. Since the CPU can find any information here stored randomly, this is known as random access memory, or RAM. It's here that the computer puts the instruction set for the current program, as well as the information you're giving the program to work with. Computer memory capacity is measured in bytes. Computers may feature 640K memory, which means 640 times 1024 characters of information, although 2 to 4 megabytes is more common today. 1 byte is basically equal to 1 character of information. The size of memory is a fairly important consideration, because if you don't have enough of it, many very useful software programs won't be able to run, or may run too slowly to be practical for you. Windows 3.1 is a very popular software program, and it should have a minimum of 2 to 3 megabytes or more to run efficiently. Large RAM will also allow some programs to run faster. Let's use an example from an office. Let's say you have a very small desk, and you're working with several blueprints and letters from contractors. If you spread the blueprints out on your desk, you'll have to keep running back and forth to a filing cabinet to look at the letters. With a larger desk, you can spread it all out and work with everything at once. Similarly, large RAM gives the CPU the space to lay out everything you want to work with all at the same time. If you do not have enough space, you'll have to do some work. Save it onto disk, clear the desktop, load the next thing you want to work on it, store it, clean the desktop, and so on. And so plenty of RAM is worth the investment in terms of the time and convenience offered. If you intend to use programs for creating graphics, or the programs you run employ graphics heavily to make them easy for you to use, a large RAM is an absolute essential. There will be 1 or more disk drives in your computer. These serve as long-term storage memory for the system. They may be used to store programs, data, or graphics. When power is turned off to the computer, the RAM will forget everything that's presently in it. If you want to save all the work you've just created, a couple of keystrokes will command the CPU to save the contents of the RAM onto disk. Disk drives are most commonly one of 2 types. A hard disk is usually installed inside the main computer's chassis, but you can get hard drives that sit separately outside it. They are very fast, meaning that you may have only to wait a second or two to get a program or file to load. Hard drives today have fairly large memory capacities and are usually available from 40 megabytes and up. 1 or more floppy disk drives may usually be found on the face of the computer. Floppy drives are not as expensive as hard drives, but they are slower and do not have as large a storage capacity. Floppy drives use removable floppy disks, and they may be either 3.5 or 5.25 inches in size. Floppies are meant to be inserted and removed from the disk drive, and if you use them, you'll quickly build up a large library of these disks. If you do not have a hard drive, you'll be storing your files on floppies. And when you're using a hard drive, you will use floppy disks to make backup copies of your work. Anytime you buy software, it will come on a floppy disk of some sort. You can transfer these software programs to your hard disk, which will make them much faster to access and more convenient to load. Most of the time, you will communicate with your computer by way of a keyboard that's connected to the computer by a cable. There is a complete set of keys, similar to the keys on a typewriter keyboard, as well as several special purpose keys that perform dedicated and often different functions for the various software programs you will use. All computers require a monitor. This displays the information that you're typing into the computer, as well as providing the computer's responses to what you've told it. It can also display graphics, pictures, charts, and diagrams. Some monitors, like this one, can show full color. Others, called monochrome monitors, only show black and green or black and amber. These are used instead of black and white because studies show that they're easier on the eyes after long periods of use. Several years ago, manufacturers began selling laptop computers. Laptops have CPU, monitor, keyboard in one remarkably small package. They are small enough that you can literally work with them on your lap. In order to save space and weight, laptop monitors do not usually use television-style picture tubes, but rather use liquid crystal displays, commonly known as LCD displays. Laptop displays are available in monochrome and in full color. Now, let's take a quick look at one last basic way that you can talk to the CPU, the mouse. The mouse is a small box with a small ball on the bottom of it. It allows you to move it around a tabletop. As you move it, electronics inside sense the movement of the ball and tell the CPU how far it moved and in what direction. On the monitor, there's often a small arrow known as a pointer, which moves as the mouse moves. By using the mouse, you can make the pointer point at various parts of the screen and use the buttons on the back of the mouse to click, which tells the program that you've performed an instruction. The mouse can also be used with many graphics programs as a drawing tool. So far, we have only looked at what we're doing on a monitor. Say we need to send a copy of some work to a colleague. Well, we can save it on a disk and send the disk. Or we can use a printer to make a copy on paper, which is known as creating a hard copy. The most common types of printers in use today are the dot matrix printer, which uses patterns of small dots to form letters and graphics. Printing is done using cartridge ribbons that look a lot like typewriter ribbons. It's common for these printers to work at 2 speeds. Draft quality type is very fast to print, but the printer gets the printing speed by printing fewer dots, and so the type isn't as correctly formed. Letter quality printing is usually slower, but the larger number of dots printed gives far better looking type and graphics. One place the difference between the two printing styles really shows is in graphics. Letter quality allows you to draw pretty smooth curves. Draft quality gives curves and diagonals a staircase look. Some dot matrix printers can accept single sheets of paper. Some are equipped to automatically feed single sheets. All of these printers are equipped with a tractor feed mechanism, which uses special paper with rows of holes down either edge to pull the paper through. The paper is perforated, so the holes can be easily removed and the pages separated. Dot matrix printers can be found in 2 sizes, those that can handle 8.5-inch wide paper, and those that can handle 14-inch wide paper, which is often used for accounting or other office purposes. Naturally, smaller widths, such as labels, can be used with either size printer. Another popular printer is the laser printer. In these devices, the CPU causes a small laser to scan a drum, like a drum in a photocopier. The drum then picks up powdered ink or toner in a pattern of text or graphics and transfers it to ordinary paper, just like a photocopier. These printers are capable of extremely high-quality work, complete with many, many typefaces and excellent quality graphics. In fact, probably the only way to get printed work of higher quality is to have it commercially typeset and reproduced. Laser printers are usually designed for use with 8.5-inch wide paper. Wider forms can be used by having the CPU simply turn the information sideways and print it on a longer sheet. Up and down printing is known as portrait mode, and sideways is known as landscape mode. The printer may be connected to your computer one of two ways. It may use a serial or a parallel interface. Either way, it will be connected by a cable. Most computers have both interfaces these days, and some have two of each. Other devices can be hooked up to serial devices, such as modems, which will allow you to send and receive computer data over the telephone lines. This is a very quick tour of a very basic computer system. We will come back to the hardware in a few moments, but for now, let's take a closer look at software. There are thousands of different software programs available for you. Some play games, draw, write, perform accounting, or many other functions. Software divides easily into two groups: data and programs. Data is usually information that you provide to the computer. It can be text, like a report that you may type in. It can be a drawing that you worked on with a mouse. Or perhaps it may be input from a device that senses the temperature and reports it to the computer. It could also be a list of telephone numbers compiled by someone else. Perhaps a directory of all the skiers that visited a certain motel in Aspen last ski season. Data is stored on either hard or floppy disks as data files. Programs are either purchased or specifically written because they do a specific task that you need done. Software programs manipulate data or perform mathematical calculations. Some programs are pre-programmed instructions that reside in the read-only memory or ROM. These ROM resident instructions are more permanent in the computer's memory than the software or programs that you purchase. These instruction sets are often referred to as firmware. Perhaps we should discuss operating systems. Your IBM or compatible probably runs DOS, which stands for Disk Operating System, which is a software program manufactured by Microsoft. An operating system acts as a link between the computer and the software that you want to use. It's usually pre-installed on the hard drive when you purchase your computer. In addition to allowing you to copy files or load programs, DOS performs many other utility functions. There are simply so many of them that discussing them in any detail is outside the scope of this first introduction. But they are pretty important to learn. A good DOS course is an excellent introduction to the software and hardware capabilities of your system. You can find out a lot more details in another tape in this series, the How to Use DOS 5 tape, which will teach you everything you need to know about DOS. Programs are written in special languages. The CPU can only understand electronic code, which boils down to strings of zeros and ones. Now, working with zeros and ones can be fairly difficult for people to remember, and so programming languages were developed. Some programming languages, like BASIC, read a lot like English, but the CPU has to do a lot of interpreting, so BASIC programs do not run as fast as some others. You do not need to understand how to write a program in order to get one to run. Software companies pride themselves on creating products that are user-friendly, meaning you don't have to be psychic to understand how to get the programs to work for you. Good software programs today are known as intuitive, in that the user's intuition is often all that's required to perform a desired command. Let's take a look at a more common type of program to see how the computer will work with it. Let's consider a spreadsheet, then a database. We'll take a look at a word processor, and we'll evaluate desktop publishing. The spreadsheet most commonly exists as an aid to accounting, annual reports, or other business purposes. Here is a sample of a simple spreadsheet that shows monthly sales in different areas of the country. Microsoft Excel is a wonderful program for creating spreadsheets that are clearly laid out and easy to understand. Excel will also allow you to take information from a spreadsheet and express it in graph form in full color. Spreadsheets are powerful programs that let you manipulate data in many ways. So far, we just have a simple column of figures. By using a feature of the program known as AutoSum, it can automatically enter the numeric total of the figures into a cell that can be referred to as the total. One of the greatest uses of spreadsheets is to create what-if scenarios. In other words, what if we change one number? What repercussions will it have on the rest of the spreadsheet? And sophisticated modern programs like Excel have the ability to take numbers and convert them to charts. Spreadsheets can be used for much more than financial calculations. Scientists and engineers use them to keep track of information and measurements from experiments. Programs like Excel have built-in features that will quickly analyze mountains of data, calculating averages, performing statistical breakdowns, and more. The user can utilize pre-programmed functions or create their own. Another popular computer function is to manipulate databases. A database is an electronic version of a file drawer full of index cards. The simplest way to show you how they work is to give you an example. Here is an example of a typical database, keeping track of business contacts. A database program can perform many functions, such as sorting, or perform other commands, such as finding a particular name. Database programs can also extract information from databases. For example, this sophisticated database can set certain criteria, such as print a list of all Chicago lists that are involved in textiles that have an annual sales figure above $10 million. Each entry in a database is known as a record. A record may contain several fields. Name is a field, phone number is another field. With a little preparation and practice, you will be able to set up a meaningful database, perform an extraction based on your criteria, and take those names, addresses, and so on, and merge them with a form letter to create personalized business documents. Of all of the software programs currently in use by the business community, word processors are probably the most popular. At first glance, a word processing program seems to perform much like a typewriter. Many word processors have the typewriter function, but that's just the beginning. A word processor is all of the things that a typewriter could ever be. Microsoft Word is an excellent example of a modern word processing software program. To begin with, you can simply start typing text in. Nothing will appear on the printer just yet. It's all displayed on the monitor. What happens when you make a mistake with a typewriter? Well, you have to use correcting ribbons or whiteout. But if you realize later that you've left a word out, you pretty much have to type the page over again. With word processing, you simply correct your error or insert the missing word. And then, when the document is absolutely perfect, you can send it to the printer. For those of us with limited writing ability, programs like Microsoft Word offer spelling commands, thesaurus modules, and grammar checking features. Word processors feature many types of editing commands. You can delete an entire paragraph, a word, or a sentence with a few keystrokes. A paragraph that may look better in a different location can be moved. Sometimes it's useful to be able to copy a block of text. With a word processor, you can do this with a couple of keystrokes and moves of the mouse instead of retyping. Most word processors will let you make important words or paragraphs bold, italic, or underlined. You can do this either as you type or afterwards. Depending on the printer that you are using, you can even change the size of the type. You can set the margins on a page and change them whenever you wish. Breaking up a large paragraph into smaller ones only takes a few keystrokes. Once your document is exactly the way you want it, you can save it as a file on your hard or floppy disk. Or you can print it on your printer. Now, since this is an introductory lesson, it's not too soon to teach you a rule that's absolutely important for new and old computer users alike. You must always save your files and make backup copies. There are no exceptions allowed. This rule cannot be emphasized too much. It's also a good idea to save your files from time to time as you're working on them. This way, if power is interrupted to your computer, you will not lose anything, except for the material you added or last changed. Careful users will save a file they've been working on to both hard and floppy disks, so that there are 2 copies of it. And then, even if the power was cut and you may lose the file from RAM, a backup copy on the hard disk will exist. Should you suffer a hard disk crash, you will always have a backup copy on a floppy disk. While we are discussing the importance of backing up copies of your files, we can also mention tape backup systems. Tape backups are specially designed recorders that record the magnetic information on your files on reel-to-reel or cassette tapes. Literally oceans of information can be stored in these devices. The tapes take a tiny fraction of the space that a file cabinet would. Perhaps we've spent as much time as we should on preserving your data. We've discussed several types of software programs, and we should mention in passing that there are software packages available, such as Microsoft Works, that contain a spreadsheet, a database, and a word processor all in one. You will find it worth your while to take a careful look at programs like these, simply because it's easy to transfer data from one of these programs to another. And all sections of the program will have some features in common. This means that you will be able to use advanced features faster and in more places, simply because you have fewer commands to learn. From word processing packages, we can move to a family of programs called desktop publishing packages. Desktop publishing allows you to take text and graphics created from other software programs and incorporate them in a professional-looking publication format. Newsletters and brochures are but a few examples of the power of desktop publishing. With popular desktop publishing packages, you have access to hundreds of type styles or fonts. You can create ornate or decorative title pages, resize type, add borders, and so on. These programs will also allow you to place graphics, whether charts, graphs, or drawings, into one or many pages. The graphic sizes can be altered. Titles or captions can be added. All the type sizes and styles can be changed or manipulated. You will have the option of seeing how everything will look on a page before you commit it to print. In some programs, this function is called Preview. This is also referred to as WYSIWYG, which is what you see is what you get. It's possible for your computer to run more than one program at the same time. One of the best examples of this today is the Windows program. Windows is known as an operating environment, and it has many features. Windows allows you to run a program like Word, and while you're in the middle of it, you can open a window to another program like Excel, work with a spreadsheet, and then return to Word by closing the window. By using a program like Windows, you can work in several areas simultaneously. You can take information from one program, and with a few keystrokes, you can apply it to another. An overview like this presentation cannot begin to show you all of the features of all of the programs, but by now, you should have a nodding acquaintance with what these types of programs are for, and be able to ask the correct questions when shopping for a spreadsheet, database, word processor, or desktop publishing package that's best suited for your needs. Now that we've been introduced to the basics of hardware and software and seen how they work together, we can return to the hardware and take a look at some of the details and a few more pieces of optional equipment. These are the pieces of information that will probably help you finalize your decision of exactly which system and options are best suited for you. Making sense out of it is all going to mean understanding a few technical terms, but they are not all that difficult to grasp, and they will help you make some very important choices. One of the first things you will consider is how fast the computer runs. Now, any computer is going to run faster than you can hope to do the work by hand, but with human nature being what it is, it's surprisingly easy to become impatient waiting for the CPU to do things or to even load files. There are also some practical considerations. Graphics programs, especially graphics programs with moving or animated graphics, require enormous numbers of calculations to run smoothly and in real time. Handling large amounts of data also takes time, and the difference between a few millionths of a second per calculation can mean minutes or more while you wait for the CPU to perform. Every computer has an internal clock that's used to keep everything in step and synchronized properly. Clock speeds are expressed in terms of cycles per second, or hertz. 1 hertz equals 1 cycle per second. To give you a starting point, the alternating current you get from an ordinary household outlet pulsates at the rate of 60 Hertz. By computer standards, that's very slow. Computer clock speeds run in the order of millions of cycles per second. To make things easy to understand, these figures are given as so many hertz, or 1 megahertz equals approximately 1 million cycles per second. IBM-compatible computers generally run an Intel CPU chip. Most computers sold today run 286, 386, or 486 chips. The higher the number, the more powerful and faster the processing ability. One way to increase the speed at which a computer can process information is to increase the clock speed of the computer. One of the older models, the 286, had a top speed of roughly 16 megahertz. Its successor, the 386, started at 16 megahertz and, by replacing the clock card, can run as fast as 58 megahertz, nearly 3.5 times faster. For 386 computers, 25 or 33 megahertz are typical operating speeds. All computer data is expressed in a system called binary, which reduces everything to strings of zeros and ones. Each 0 or 1 is called a bit, and the CPU sees each bit as a tiny switch that's off if the bit is 0 or on if the bit is 1. Bits are looked at as words in groups of 8. Each 8-bit word is called a byte. And memory, whether it's RAM or disk capacity, is expressed in thousands of bytes, which is kilobytes, or millions of bytes, which is known as megabytes. Now, 1 kilobyte is not exactly 1,000 bytes, it's actually 1,024 bytes. The data file for a single-page business letter is commonly 2,000 or 3,000 bytes, or 2 or 3 kilobytes. While we're on the subject of memories, and the idea of megabytes is fresh, we should mention that there are a couple of different types of RAM. The normal memory is what's included as standard with the computer when you purchase it. In the case of a 286, it may be 640K or kilobytes. In the case of a 386, it can be 4 megabytes. Incidentally, when you're talking with someone who deals with computers a lot, you might find that they abbreviate even further and refer to 640 kilobytes as 640K. And it's written like this. 4 megabytes are often referred to as 4 megs. If the standard memory available in your computer is not enough, you can simply add more memory. Now, there are two kinds of memory that you can add to your computer: extended or expanded memory. Each of these types of memory requires software that can specifically use it. Your computer can use one or the other, but not both. Expanded memory can increase the capacity of the RAM beyond 640K. Extended memory is the popular choice today and can be used with 286 or higher computers. Windows loves extended memory. This also increases the size of your RAM, but with a difference. You, the operator, cannot use it. Extended memory is used by programs such as Windows as space specially devoted to the program for doing its work. A fairly recent addition to the family of options available for your computer is the CD-ROM. It's a very exciting feature. A CD-ROM looks like a normal compact disc player, and it plugs into one of the optional accessory sockets at the back of your computer. There's more circuitry inside a CD-ROM than in a normal compact disc player. The compact disc, scanned by a tiny laser, has the capacity to store huge amounts of information. Your CD-ROM can play music through your computer. But there are CDs available with storehouses of information. A few examples. A U.S. atlas, which loads detailed color maps of the U.S. into your computer and displays them on your monitor. A program on the disk lets you select any 2 points in the country and will plot out driving instructions for the shortest, fastest, or most scenic route between them. There's also an almanac and fact book loaded with other information. All of this is on one CD. There exists a business phone book listing 9,200,000 business telephone numbers from over 5,000 nationwide Yellow Page directories. The directory can be searched by zip code, city, company name, or state. Or you can enter a phone number and the directory will tell you which business it belongs to. You can also purchase language lessons that feature text which will guide you through grammar, vocabulary, and the construction of languages such as French or Spanish. They also offer audio tracks that play through your computer so that you can learn to speak. And the library of information available on this format is growing at a tremendous rate, and already includes Shakespeare, movie reviews, encyclopedias, art reference, art and graphic images that you can use in your own documents, and more. We've mentioned several times already that the CPU is a device that controls everything that goes on in the computer and does all the number and information crunching. The whole system can be speeded up considerably if you equip your computer with a coprocessor known sometimes as a math coprocessor. This microchip takes over the job of performing all the mathematical calculations from the CPU. This leaves the CPU free to accept new information, format it, and send it where it has to go. The net result is an increase in speed up to 50% or more, depending on the particular program that you're running. Your software must be able to handle the special coprocessor. Simply adding the chip will not speed up your system unless the software can specifically handle it. Another thing that affects how fast a computer runs is the efficiency with which the various components can transfer information amongst themselves. Data, as strings of binary zeros and ones, flow on electronic freeways between points like the CPU and the memory. These freeways are also called data buses. The speed and efficiency of traffic flow on a freeway depends on how wide it is. The simplest data buses look at words 8 bits at a time. Data and programs can flow far faster on a 16-bit data bus. There are modern computers with 32-bit data buses that are faster yet. At least one manufacturer also manufactures a computer with two 16-bit data buses that work slightly out of step with each other. The second bus starts loading up its word just after the first begins to fill. By the time the first bus has sent its word to its destination, bus number 2 is already full and fires its word after the first. By the time that's done, bus number 1 is full again, and the process repeats. This system is almost as fast as a 32-bit data bus, and the system is said to emulate a 32-bit data bus. There are quite a number of optional devices that can be connected to a computer. Additional disk drives, CD-ROMs, scanners, and so on. Just so all this doesn't become chaotic, the industry has adopted a system called SCSI interfaces. This simply means that two devices such as a hard drive and a CD-ROM that are SCSI compatible will connect to each other without additional printed circuit cards to make them compatible. We've taken a look at how you can set the computer up internally to process a lot more data a lot faster. To improve the process even further, we have to look at making another interface more efficient. And that interface is the one where the computer does most of its talking to you. The face of your monitor is a definite size, and you can only display so much information on it at one time. That amount of information largely depends on how clearly it's displayed. If you're looking at type that's fuzzy or badly shaped, your eyes will tire quickly. If you look closely at the monitor screen, you'll notice that every letter of type and every line of graphics is actually made up of a pattern of tiny dots. If there are more dots, the monitor can paint a picture with finer detail. The number of dots is referred to by a monitor specification called dot pitch, which is a number that indicates the pixel size. Pixel stands for picture element, and each pixel is a collection of 3 dots of primary colors that the monitor uses to put text and graphics together. From a pixel containing 1 red, 1 blue, and 1 green dot, the computer can produce all the colors that the monitor can display. On extremely high-quality monitors, the number of colors available can run into the thousands. The smaller the dot pitch, the smaller the pixels, which means there are more of them, which also means that the monitor can display a clearer picture. Interestingly, printers use the reciprocal of dot pitch to express how finely they can print. So you'll commonly see a printer described as resolving or printing, say, 300 dots per inch. With more dots to paint on the monitor face, the CPU would spend more time figuring out which ones should be lit and what color they should be. This would cut computing speed down seriously, and that might not be an acceptable trade-off. So the monitor uses its own special memory to store the really detailed information about the screen display. This memory is found on the VGA card, which is installed on the computer's logic board. VGA stands for Video Graphics Array, and it will allow a high-quality monitor to display an image 640 pixels wide by 480 high. In addition to being sharper than EGA, VGA monitors can display much better color. An EGA, or Enhanced Graphics Adapter card, will let the monitor display an image 640 by 350 pixels, with any pixel being one of 16 colors. An SVGA, or Super VGA card, has even more memory and will display a much sharper image, 1024 by 768 pixels. This is well over twice the information on a simple VGA card. There's also an Ultra VGA card available. This puts out an extremely detailed image of 1280 by 1024 pixels and can display 256 colors. We'll conclude our introduction to the personal computer for now. We hope you'll feel a lot more comfortable about many of the terms you'll run across when you set out to buy your computer. And, with any luck, we've prodded your curiosity about all the genuinely wonderful equipment, programs, and accessories that are available just waiting for you to discover. A good strategy would be to think about the things we've looked at today and review this tape once or twice before visiting your computer dealer. This little pause will help the terms and concepts gel in your mind, and you'll be able to ask the questions you need to ask to select the computer that's exactly right for you. And finally, we'd like to remind you that Advanced Media Group is producing an ongoing series of videos that are tutorials for a number of popular software programs. They will guide you step by step through the program basics to help you start using the advanced features quickly and easily. Consult your dealer for the availability of the Getting Started video course, which will teach you everything you need to know about setting up your new computer system. I hope we'll see you again.